Good morning all of you. Welcome to Standard 8th. So, today we are going to start here with Maths chapter 1, that is rational number and irrational numbers. So, for that purpose, let us summarize what you people have already studied in Standard 7. So, what you people have studied? They are natural numbers, whole numbers, integers and rational numbers. Let us see one by one these numbers. So first of all, natural numbers. Counting numbers are called natural numbers. So counting starts with 1, therefore 1, 2, 3, dash, 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 etc. They are natural numbers. Whereas whole numbers means entire numbers, all natural numbers together with 0 are called whole numbers. Now let us turn towards integers. What integers are? Integers are nothing but natural numbers, 0 and all opposite of natural numbers. So integers are a collection of natural number with a 0 and all opposite numbers of natural numbers. Now the rational numbers. So rational numbers are the numbers which are in the form of m upon n. Numbers which are in the form of m upon n, but the condition is n should not be equal to 0. So such numbers are called rational numbers. Now let us see a number line. So as the name indicate, number line. So this particular line is associated with different numbers. The numbers which are to the right hand side of the number line, they are called as positive integers. Whereas the numbers which are towards the left hand side of the number line are called as negative numbers or negative integers. So here is an example from your page number 1. We have to represent 3 upon 4, minus 3 upon 4 and 9 upon 4 on number line. So look at these three rational numbers. As the denominator of these three rational number is 4, what we have done? We have divided each unit distance into 4 parts. 3 upon 4 and 9 upon 4 are positive rational number. Therefore, these two positive rational numbers will lie on right hand side of 0. This is the right hand side of 0. Let us see 3 upon 4. So as we have divided each unit distance into 4 parts, let us count from 0. So this first number is 1 upon 4. Second number will be 2 upon 4. Third number 3 upon 4. So this is our 3 upon 4. In the same way, we'll go towards 9 upon 4. This will be 4 upon 4, 5 upon 4, 6 upon 4, 7 upon 4, 8 upon 4. Now the next number will be 9 upon 4. So 9 equal parts to the right hand side of 0 is 9 upon 4. Let us turn towards the negative 3 upon 4. So minus 3 upon 4 will lie towards the left hand side of 0. So here we'll start counting. This will be minus 1 upon 4, minus 2 upon 4, minus 3 upon 4. This particular number is minus 3 upon 4. So you people can practice different examples from page number 1. There you have to write different numbers. You have to represent different numbers on number line, but the denominators will be different in each case. So whatever is the denominator, divide each equal distance or each unit distance into those equal parts. Here is an example from our State Board Standard 8th textbook, page number 2, example number 2. So here we have to observe the number line and answer the questions which are given below it. So the first question is, which number is indicated by point B? Where is point B? Point B is here. Here the number line have been divided into 4 equal parts, or each unit distance on the number line have been divided into 4 parts. So let us count for number B. So number B will represent, start from 0. So it will be minus 1 upon 4, minus 2 upon 4, minus 3 upon 4, minus 4 upon 4, minus 5 upon 4, minus 6 upon 4, minus 7 upon 4, minus 8 upon 4, minus 10 upon 4. So B will be minus 10 upon 4. B represents minus 10 upon 4. Let us turn towards A. This will be minus 11 upon 4 and A will be minus 12 upon 4. So after dividing 12 by 4, you will get 3. Let us start to E. The number which is indicated by E is 0, minus 1 upon 4, minus 2 upon 4, minus 3 upon 4, minus 4 upon 4, minus 5 upon 4. This will be minus 6 upon 4. E represents 6 upon 4. What about F? Start counting from 0. So as the numbers are towards right hand side of the number line, they all will be positive. This will be 1 upon 4, 2 upon 4, 3 upon 4, 4 upon 4. F represents 4 upon 4. But 4 upon 4 means 1. As 4 is divided by 4, we get 1. Let us turn towards C. This is 4 upon 4. This will be 5 upon 4, 6 upon 4. C represents 7 upon 4. Just keep continuing. 7 upon 4, 8 upon 4, 9 upon 4. D represents 10 upon 4. Here we are with the comparison of rational numbers. We are going to compare rational numbers. So suppose A upon B and C upon D are any two rational numbers. Then 3 conditions are essential for comparison. Let us start with one by one. If, I'll write here, if A into D, if it is greater than, I'll write here greater sign. So if A into D is greater than B into C, then first rational number first rational number will be greater than second rational number. So A into D, if it is greater than B into C, then A upon B is greater than C upon D. Now the second condition, if A into D is equal to, if A into D is equal to B into C, then these two rational numbers will be equal. In the same way, if A into D is less than B into C, then first rational number A upon B will be smaller than second rational number. So these are the 3 different criteria for determining smaller rational number or greater rational number. We'll turn towards page number 3 from your textbook, practice set 1.2. So in practice set 1.2, we have to compare the numbers. Compare the numbers. First example, -7 -2. So here we are going to compare -7 and -2. First of all, let us see the comparison between 7 and 2. In 7 and 2, 7 is greater than 2. 7 is greater than 2, but as the number line suggests, the numbers which are towards the left hand side of the number line becomes smaller and smaller. So -7 lies towards the left hand side from in the number line. So -7 will be smaller than -2. Let us try one more example, that is example number 9 from your textbook. So here we are. 12 upon 15 is first rational number and 3 upon 5 is another rational number, and we have to compare these two rational numbers. So for comparison, we'll take first of all A, B, C and D. So here we are. A is 12, B is 15, C it is 3, D it's 5. Let us start with A into D. How much is A into D? It will be 12 into 5. That gives us 60. Let us take B into C. B into C is 15 into 3 is equal to 45. So we'll compare A into D and B into C. A into D is 60, B into D is 40. So after comparison, we come to the conclusion that A into D is greater than B into C. A into D is greater than B into C. Therefore, rule suggests that if A into D is greater than B into D, then first rational number, that means 12 upon 15, will be greater than second rational number, that is 3 upon 5. Let us learn decimal representation of a number which is rational number. Problem set 1.3, we'll try one example, that is 9 upon 37. We have to represent 9 upon 37 in a decimal form. So here 9 is divided by 37 by your traditional division method. So after 9 I have taken 4 zeros. 9 cannot be divided by 37, so I'll consider it as 90. 37 twos will be 74. Subtract 74 from 90, we'll get 16. Take 1 0 or carry 1 0 from here, that gives us 160. 37 into 4, 37 into 4 will give us 148. Subtract 148 from 160, we have 12. Now carry another 0 from here, so it will be 120. Start 37 into 3. 37 into 3 will give us 111. Subtract 111 from 120 will give us 9. So we have started our division from 9 and we have reached once again to 9. So whole division will get repeated, or there will be repetition of 2, 4, 3. So that will be represented as 0.245. 4, 3 bar. This bar indicates that 2, 4, 3, these numbers will come again and again and again, or this division is never ending or non-ending division. There are few examples in practice set 1.3. You can try those examples by using simple traditional